Good morning, everybody. Thank you for joining our webinar today, the ALUMEGA pin connection for post and beam, just some timber connection technology for your Wednesday morning. My name is Chris Chukiji, and I am the marketing account for Rotoblast here in North America, and just wanted to welcome you to the presentation today. If you have any questions at all throughout the presentation, we'll look to answer those towards the end. On a computer in the top bar, you should see the Q&A button where you can type your questions in. If you're on a phone, in the bottom right-hand corner, you should see three dots. We'll open up that same menu and you'll be able to find your access to the Q&A section. So without further ado, I'm going to pass it on over to our presenter for today, Alexander Alvarez. Go ahead, Alex.
Okay, thank you, Chris. Hello everybody. Good morning or good afternoon, good evening. My name is Alex. I'm the tech consultant for the US, and today we're going to be talking about the ALUMEGA, the pin connection for post and beam. So let's get right to it. Okay, so and just like give a little brief history about timber construction. Timber construction has been around for a while. Back in the older days, when things used to be when before steel and concrete, we would just make these cabin houses out of the logs. As you can see on the picture on the left, very simple, very cozy. When you think of like a very like cozy house, I hope majority of you guys might think like of a cabin house, like you're away from the society, you feel very comfortable. Um, And usually when you think of a cabin house, you don't think of a very tall like skyscraper or anything. You just think of very small like one level floor and that's it. But then later on, as you know, as engineers grow and they want to push the limit of how we think, how we build, we start seeing actual wood skyscrapers. So a couple of examples of them. You can see that on the right side, we have a couple of wooden skyscrapers. One are about 18 floors, and then the one in Austria is about 24 floors. And as you can see, we are still using timber. It's not something new. It's just a revolution, as the title would say, the timber revolution, because we're revolutionizing, we're changing how we use, how we utilize wooden materials. And to go about it, there's a couple of things you have to think about. Obviously, fire protection is one thing, um, waterproofing, but also, since we're talking about our one of our connectors, you also have to think about the structural side of it. So for very tall skyscrapers, one thing you have to think about is how to make sure how you're going to connect them, like how you're going to go about connecting these wooden beams, the wooden columns. And so there's a couple of ways to go about it. There's two type of connections: a hinge connection and a fixed support connection. Hinge, it's another way for saying hinge is pin connection, and it's just a way to like it reacts in two directions. In shear, which is up or down, or if you were to think of a 3D model, also from left to right. However, since I said it only deals with in two direction, it does not deal with the bending moment, the rotation side of it. But that's where the fixed support comes into play. Fixed support deals in three directions: shear, up and down, left to right, and even the bending moment. And as you can see, is one way it's kind of hard to visualize how that would look like in a wooden connection. So usually fixed supports are like you'll see them most often when like a beam is like sort of glued right into the walls. For or like for example, say like the wall side is a concrete wall, concrete core. Um, you can stick the wood inside of it, but then you start thinking, okay, this might not be a good idea, or it might be too expensive, too complicated, and so that's why many people, some of the engineers prefer pin connections. It's pretty simple, and to deal with the rotation, to deal with moment, there's another system in play to deal with those type of, of forces. So um, that's why you see a lot more often hinge connection when it comes to to timber. Um, and usually you see them sort of like this. Hinge connections, you see them like they're like hangers. You connect the beams or the joists into either a knife plate connector or one of these bucket connectors where you just slide the beam on top of it. Um, they both do get the job done. They both hold the beams. They both hold the weight and the load. However, you gotta also think about the aesthetic as well. Some people they just want to see wood. They don't want to see no sort of of metal show. Just just for aesthetic reasons. Um, the other thing to think about is how like the exposure, how much can the danger it can cause. Um, if it's hidden, obviously not only do you not see the metal, but you also prevent the metal from being exposed to the environment. And the environment can be from from the weather, rain, or the other thing is also fire as well. Um, if fire were to, if you ever felt metal during the heat, especially right now this month, where like it's high 100 degrees, if you were to touch your car, touch a doorknob, and it's been exposed to the sun for so long, it's very hot. So it's metal is very conductible. So people prefer to keep the metal hidden, so so that in case there's a fire, the fire wouldn't heat up the metal and it wouldn't make the wood um, like burn up as quickly as possible. And we can talk more about fire protection later on the slide, but that's something to keep in mind when it comes to these type of hidden connectors. So there are many ways to go about it, to make connecting these joists into the main beams or main columns. The most simple ones are these screws right here, are fully threaded screws, the VGZs. Um, they have a cylindrical head on top, so that means that when you drill them into the wood, it doesn't crush the wood. It actually just able to slide in right into the wood, so it leaves like a very clean hole. So it's easy to cover up with a wood cap. Not only that, our VGZ also really strong in terms of in shear. For example, if you look at the picture on the right, you see we have cross screws. There's two screws inclined going in two directions. One into the main beam, main column, and the other one going into the secondary beam or the joist here. Um, if you have a look at our technical data sheet for our VGZ and VGS, you can see that these a couple of these VGZ screws can handle up to 1,000 pounds of shear. Um, Due to like not only the strength, the strength material, the property of the screws, but also because of the withdrawal capacity as well. So these incline screws are able to give you these huge amount of capacity because of the withdrawal forces and also the shear forces of the screws. Um, so they're very simple, very easy. If you have a slot, you can easily just drill them 45 degrees. You don't have to measure it by eye. However, as I said before, by eye it looks as going straight, but if you were to get an X-ray vision, that's not the case always. Sometimes they may be perfect, like the picture on the left. This is a perfect installation. But if you see on the picture on the right, you can see that, it comes off kind of crooked. So it might not be a big deal, yeah, you can see this is X-ray, so whatever's inside, no one can see. But um, what if somehow you wanted the screw to come out one direction and then someone comes to the side? You can see here that one of the screws here was trying to come off, like right here. Like you can see if it was a bit longer, instead of going in the middle of the screw in the middle of the beam, it could have come off on the side. So it's not always the case. Obviously, someone who's an experienced installer would know, like they had to drill it with a lot of force or drill it perfect. They would know how much force to apply. But It's just something to keep in mind. It's there's it has to be everything has to be done perfectly, and you have like not there's 90% chance that it will be perfect like the picture on the left, but those the other 10% it can ruin the aesthetic of the connection. So there's that, and obviously the screws are limited to the capacity and also by uh, the, the width of the beam and the depth of the beam. So you can only fit about like two screws in there, and that's it. Um, so yeah, it's a couple summary of what I was mentioning. It's low cost, very easy. It also gives you fire protection as well because you have the screws into the beam, so they're protected by the outer layer of the wood. You don't have they're not very exposed. They're hidden, but obviously you're limited by the section. So depending how wide the beam is, you can fit up to maybe up to at least one screw, one cross screws on each side. If they're wide, obviously you can fit more, but you also got to think about the distance, minimum distance as well. So that's something to keep in mind. But then you also have these type of hidden connections as well. We have the Alu series, we have the Alu Mini, we have the Alu Midi, and the Alu Maxi. Um, there are knife plates connection. There's many ways to install them. Either with our self-drilling dowels, or SPD, or our smooth dowels. You can either drill like you can see on the middle picture. Um, the middle picture here. This one doesn't have no hole, so what you can do is just connect the beam, slide the beam in, and you can make your holes, space them out. You can and add as much dowels as you want. Obviously, making sure you respect the distance between each hole, so that you're not like creating cracks on the beam. Or sometimes you don't want that. You just want to come into place. You just want to drill the holes on the wood side only. Don't worry, we have that as well. We have knife plates with our holes in them as well. So there's that. Or you can just use a self-drilling dowels and just drill the dowels into it, into the wood, and it will go into the knife plate. And yeah, there's one way to go about it. Um, but obviously, not everything is perfect. There's always some pros and cons. Um, well, as I said before, pros, since these are knife plates, obviously they can deal a lot. They can handle a lot bigger load. They help with axial and lateral and uplift resistance, so it can deal with like forces going from the up and down, left to right, and if they were to be pulled, they're able to give you that resistance, a lot more resistant. It's concealed as well, so you're not seeing them. If you were to walk around and look up, you can fix them also on concrete and steel. Um, on the base plate, you can see that a lot of these have the bigger holes. Those are used for like the bigger concrete anchors or other anchors to connect into the steel or into the concrete. Um, but the cons also comes down to the section as well. Maybe like you can see these are knife plates and they get bigger. So this is about 4 inches. I would say are 4 inches, and it can go up all the way up to 20 inches. So they can get pretty long, pretty big. But you're limited to also the section of the beam. So maybe the beam is only it can get just about 20 inches, and we have a 20-inch knife plate, but it doesn't give you the capacity you're looking for. So that's something to keep in mind, and also the fire resistant as well. You can slide a dowel, the STA, where you can just like hammer it inside, but then you have to make sure it's not going all the way to the other side of the beam, because then now you have to cover up both sides of the beams, and it's not a big deal, just as just putting caps, but every drill, every cut you make it's $1 or more than $1. It's a lot, it's money. So usually fabrication of wood can be expensive, so you have to make sure that you're making use of it as well. And not only that, you will also want to make the dowels hidden. You want to make sure that they're inside the wood, and there's enough layers covering the dowels. So Yeah, that's something to keep in mind. You know how, like, if you're gonna use some dowels, you have to make sure that they're very deep inside the wood, that the layers of the wood can protect it from the fire and from the heat. So there's that. So um, let's see, and then yeah, like there's just many ways to connect the alu series. And here's just a couple of pictures that of projects in the U.S. that use our alu series. This one is the AluMaxi. You can see here um, that these knife plates can get pretty big, as you can see right here in this picture, and you can also pair them up as well. So like have them like on each side, or like this right here as well. And just some more pictures here as well. Yeah, and then you can see here how it looks like. It's a clean cut. You can see like the holes on the wooden on the glulam beams. You can see here they're exposed, so probably at the end this is probably still going through the construction phase. So obviously at the end they're going to cover this up so that the heat doesn't go inside into these holes and heat up the dowels inside. So yep. But then okay, so we talked about the pros and cons of all of the screws in our alu series. But as you can see, like, you know, they get bigger. What if you want something smaller, something that can handle a lot more weight, a lot more, and can also do the job as a knife plate? And we have that, which is called the ALUMEGA. Um, the ALUMEGA is like I would say the the mega version of all the connectors, but it's able to handle a lot more capacity, despite even if it's a smaller a smaller hanger. So a couple inspirations done for the Alumega. So you may notice that like a lot of the higher capacity, one of them is that they take advantage of incline screws. You can see here some of the holes here on the hangers, they're not like they're not straight. They're kind of inclined so that you're able to um, do something like this where you have a lot of incline screws going into the beam, into the column, and then into the secondary beam. Um, we also have like this as well where they're just able to lock it into place. It's like a very like a locking mechanism. However, as I said before, everything has a pros and everything has a cons. So the locking mechanism is a good idea. However, you have to think about the tolerances as well. So on construction site, you can plan everything as much as you want on paper. You know, you can write draw the cleanest drawings ever, and then you go on site and it's off by like a 1 inch or 2 inches or off by a lot. And then you look at your paper and you look on construction site and it didn't go as planned. So wanted to think about tolerance as well. Like in case like the beams are not like the size you're looking for, you have to make sure can you adjust it a bit. Another thing as well is that with the locking mechanism is that you have to make sure that if you know there was to be like like a seismic activity, like maybe like an earthquake, a mini earthquake, or even like a very high, very windy day, you have to see like okay, can in case that happens, can the connectors be able to react the same way, in the opposite direction of the force. Um, if we look at buildings, you may notice that like when there's an earthquake, buildings tend to shake, but just a little bit amount, which is what you want. Because if something were to be very stiff, there's a lot of energy built up, and in any scenario, if it was a bigger earthquake, a very serious earthquake, the stiffer it is, the more the powerful of, of the building is to snap. That's because a lot of energy was built up. And so you want it to be able to move just a little bit, not too much. You don't want it to be swaying like a balloon, one of those like inflatable balloons where they just sway around, but you just want it to sway just enough so that it's able to handle a little bit of the lateral forces or like seismic or very windy areas. So those are your pros and those are your cons. as well. Um, and so one of the things we have to consider about when it comes to the Alamega is to handle all of these 5 points. Obviously, high shear resistance. We want to make sure is able to handle a lot of load. We also want to make sure it's demountable. So in case like maybe you want to like start all over or remove a connector because something happened, you want to make sure it's able to be easy to remove as well as easy to install. Um, of course, the economy is one thing. You have to make sure if it's expensive, can it get the job done? Can I just use one connector instead of two or three? And then the other thing we also have to think about is the fire rating as well. Can these connectors be small and be hidden and be able to protect the beam if it were to be covered up by the wood? And last but not least, the insulation tolerance, as I mentioned before. We have to make sure that there's enough a room for a room for installing the connectors. If they were to be, off by a little bit, can you just adjust the connectors? Can you adjust it in some way where you don't have to remove everything and then somehow call the people and say like, oh, we were off like 1 inch, and that 1 inch can cost you thousands of dollars. So you have to think about installation tolerances as well. And so our Alumega has we have two types. We have the header and the joist. Header side, you apply it on the header, as the name say, and then the joist, which is on the beams you're applying it to. Um, the smaller ones can be up to 9 inches of height, and the biggest one can be up to 33 inches of height. And they're all about the same width as well, about three inches and 3/4. So to to show you guys, we have uh, two type of two two types. The header side, which is you can tell by the H. That's if it has an H, that belongs to the header. So HP and the HV, and then the joy side, and you can tell by the letter, the first letter, the J, which is the JV and the JS. Um, so let's start with the header side, the Alamega HP. Um, you can see the Alamega HP, you usually are using our plate screws, our HPS plate screws. You can you apply this on the main column or the main beam. You can use our metal to timber connectors, our fasteners, our HPS plate, but you can also use other fasteners as well. So you have the coast, which is a through bolt. You can use that as well. Or you can also use maybe like for concrete chemical for use one of our chemical anchors, our SKRs, or a threaded rod, and then applied epoxy or some sort of chemical epoxy in there into the concrete side. Um, and then also as not only can you install it into wood, into concrete, but also you can use them on steel as well. So you can use our bolts or some sort of bolt to connect into the steel column or steel beam. Um, we also have the Alumega HV, which is the B stands for incline screws. So here we have the Alumega HV with our VGS and washers. As I said before, incline screws are really good. They can handle a lot more load, so our Alumega HV can give you a higher capacity. As you can see here, this is the Alumina HV. We are actually introducing a newer version of this, of the Alumega, where we're trying to make sure that in the new version, you don't need to use these washers around here. It just already comes with there's already a washer, a pre washer inside at the metal hanger. So you will see the slot will be inclined, so the screw can easily it can help guide the the RVGS screws into the wood. So just keep an eye out for that for our on a new version of our Alumega HV. Um, so that's the header side, but on the joist side as well, we also have another an incline installation, the Alumega JV, which is the same thing as the other one. However, this time instead of going up into the beam, this is going down into the beam. Um, and this will also give you a high capacity. But maybe sometimes you don't want that. You want to keep it simple, what you're always used to, which is a knife plate. And we do have that. We have the Alumega JS. These are for your. There are two versions of this. Well, one version, but two ways of installing. We have the STAs, the are smooth dowels. As you can see here, it comes with a hole, so you can just drill the holes on the wooden beam, and just tap in and tap the dowels inside. Um, and then the other way of applying it is the SPD, the self-drilling dowels. You just install the dowels into the wood, and then it will go into the knife plate, and then a little bit out. Always not all the way through, because you don't want to cover up the wooden beams on two sides. You just want to install it. You want to cover it up on one side only. So yeah, so there's many ways of installing, pairing up the Alumegas. You can pair up the Alumega HP with the JS, or the HV with the JS instead. Or you can go about it like, there's many ways of going about it. So, and also with the HP, it's really helpful because you're able to install them on concrete, and then also on the metal side as well, like steel beams or steel columns. Um, and it comes when it comes to installation options, obviously you can do there's two ways of doing it. You can do the top down, which is like what you see on the picture on the left. You leave the connectors exposed. Maybe fire rating isn't an issue for you, or I mean, I don't know when that might be the case, but fire issue might not be an issue with you, so you don't mind having it exposed, or you're gonna cover up later on. So there's these are two ways of going about it. And then on the picture on the right, there's a bottom up version where the bottom side is covered up, and you just cut the top side. So you just slide it, go down, and then work your way up, like bottom up. Just for like something for to conceal it completely. Um, but maybe sometimes you maybe have the bottom exposed, like you made a cut at the bottom, and we have a way of going about it, how to make sure that it's very concealed. So one of the recommendations we recommend is, you can go about it like this way, or you do it from the top down instead. But to make sure that you don't see the hangers from the bottom, you can use a wooden block to cover it up, and then obviously just use these wooden caps to cover up the dowels. Um, Obviously, the reason for this is either for the aesthetic reasons, you don't want to see the connectors, but also for the fire rating reason as well. It's able to prevent the fire if there is a fire at the bottom, like on the floor, and the fire, you can feel the heat and the fire go up. You have these wooden blocks covering it up. So there's that. Um, yeah, and then here you can see, like as I said before, maybe you have a bigger beam, you have a bigger load. Don't worry, you can also pair them up as well, up to three connectors. You can see here how you have like you can go about it. We also have guidance as well, how to space them out, how to space them out between each side. So we recommend about 3/8 of an inch from each other. And then you can see here there's a bolt here. What you would do is slide up one of our bolts called the mega bolts. Like you see there's a rod right here. They're fully threaded, and also the slot are also threaded as well. So you can just slide the bolt through, and is able to catch into the thread, and is able to go all the way through. Easy for installation. You don't have to like install the rod, and then somehow it gets crooked right here on the middle side. Then you have to fix it, adjust it, and then do the same thing for the other side. The threaded slot, it helps with installation, make things go smoother. Um, yeah, and so yeah, just give you an understanding like the geometry of the Alumega, like the spacing between each other, and like just give you an understanding of what that looks. And then yeah, right here, as I said before, the slots here where you fit in the bolt, they're threaded, so it just helps with the installation go smoother. Um, Maybe to make things go even more smoother, we also provide jigs as well. Um, this you can what you do is just the jig is just able to hold the beam into place. It spaces them out evenly, and you can slide in the on the rod right and through. Maybe for those who like like they want to make sure everything is like precise, a perfectionist. So the jig is able to help you with that. Um, it's just a video of how they use the jig. You can see here that they install it in the top, so that it just helps with the hold it right into place, and they just drill the rod through. You can see here it's going well smoothly. This was doing a presentation, so the stops that are happening is just the guy stopping and then talking. So it's not that he ran into an issue. Yeah, it goes smoothly, and then the guy is talking again. Yeah, and we also provide the indication as well how to go about installing them. So obviously, you want to make sure you install them correctly to make sure that you're able to get the efficiency. So we tell you like where's the top version and where's the and where it should go on top. Um, we also provide a video as well of how they go about it. Uh, Here we go. Trying to remove the sound. Ah, it's okay. Yeah, so and there's a video to showing you guys how to install the ALUMEGA, preferably the HV and the JV. Um, Also, you may notice that they use the torque wrench or a torque limiter, which is you can pair them up with your power drill. Um, the reason for that is because when it comes to any type of metal to timber connections, you have to make sure that the screws are not over torque into the metal plates. The reason for that is because obviously, if you were to over torque something, and it could be anything, like if you were to over torque maybe like one of the bolts of your car, you're kind of like over tightening it too much. It creates a lot more tension. So in case of maybe like a big something, like it hits something really big, or like it's just a good amount of force to happen, that bolt can snap because it's already built up so much tension inside before even take any load as well. So you have to make sure when it comes to metal timber, nothing's over torqued. It's perfectly torqued, And so you can see here why he's going about it with the torque wrench to make sure everything is installed correctly. And it's just a precaution, you know. If you can trust yourself with that, then go ahead. But it's always good practice doing an inspection first to see how how things are. Yeah, and then you can hear the snaps, which is just like all of the screws being like torqued perfectly that the torque wrench gives up. It's like, okay, it's good, move on, and so on. That's what you want to see and what you want to hear when something's installed correctly. So, yep. Um, as I mentioned before, tolerances is also really important. You have to make sure that when you install these hangers, they're able to deal with some sort of rotation. As you can see here, we have some tolerances in the axial direction from facing into the column, so back and forth, or left or right to left. And also there's also a way of like rotating as well, 6 degrees rotation. Um, it's just yeah, let's just give you an idea like how to go about it, like how close it needs to be to each other. You can create that tolerance if you want, or not. We also recommend you how to go about it, like how much deep into the glue and beam you need to go into. Um, and also the other thing is also to think about is like how much space it needs to have if you were to put fire protection around it, which we do provide that. We have a good range, a big range of fire protection. We have our fire stripe graphite, which is like a tape you wrap around the connector. We have the MS seal, which is just like a sealant. You can just cover it up easily, or fire sealing acrylic, and also fire sealing silicone. Um, you can see here on on the left picture, we provide a recommendation of how much of a gap you need to leave to install these connect to not the connectors, install these fire protection products. Um, we're actually doing some research with our fire stripe graphite and other sealants with a lab to determine the fire rating it can provide, which can be very helpful, especially when it comes to fire ratings. You know, you want to deal with like a 1 hour fire rating or 2 hours. Um, you want to make sure like instead of making a very wide beam, you can just use a typical wide glulam beam and just use the fire graphite just to cover it up and to give it the protection you need, or the protection based on the building code as well. So obviously you don't want to be like a very big gap, because then now, in case a fire were to happen, maybe when the fire stripe graphite, which is like an expansion sealant, so if we were to heat it up or there's a fire, the stripe expands, so it protects the hangers. We obviously recommend like a certain amount, because then if it was too wide of a gap, then it protects maybe just the beam but not the column, so not the column is in danger of getting heat up. And for those that may not know why you want layers to protect the hangers, when wood were to get burned up, you may notice that creates this very like rock, like black layer. That's the It creates this. This actually acts as an insulation layer. It protects the wood from the inside, so it it burns up the outside layer, but the inside still protected, because now this becomes less what do you call it, conductible. It doesn't The fire cannot burn this up anymore because it's already burned up. There's no wood to wrap around itself to like keep going. So as you can see here, the fire dies out and it creates like these ashes and these embers, and then just leave this layer. Obviously, the reason why we have 1 hour, 2 hour fire ratings, because in case, after the fire, you want to make sure the connection is able to stay up even after the fire. It goes to anything like a steel beam. You want to make sure is structurable safe even after being burned up. Because if you were to heat up a metal, you may notice it becomes very ductile, very bendable. So obviously you want to make sure that even after fire or during a fire is able to stay as strong as possible before it becomes too ductile and it fails. So that's the reason why we have the fire ratings. Just a little, of course, a crash history behind it. Maybe you guys may know. So, but just wanted to give you a reminder. But yeah, um, so obviously you have to create a balance between the two, installation tolerance, and the on-site gap, how much of a gap you want. So we just give you those options just to play around with it. But also, not only that, we know we give you options. We also give you options in terms of the size of the alumegas. So maybe you want an alumega. Maybe you have a 14 an 18 inch. We have the alumega 480, which is about 19 inches, but it's too big. Maybe the beam is actually 17 inches. So you can either go with a 360, alumega 360, which is about 14 inches, but it maybe the capacity isn't there yet. So don't worry, we can give you a custom made one, 420, which is about 16 inches. So you can see here that there's always we can cut them up. They're modular. There a modularity. So we can still give you the perfect size you need or the size you're looking for. So to make sure you're able to handle the loads you're dealing with. So here are just some more pictures of the Alamegas. On the construction sites, you can see on the secondary beam, you can see like they use two instead. And then you can see like we have this layers around it, and then the column. Um, and then you can see here like the construction site, how they go about installing the mega bolts, especially like around here. Get my laser pointer. Like right here, you can see like there's a very small gap. Like how are you gonna slide those bolts inside? Don't worry, it is possible. These people have done it before. They've done it. Um, yeah, and then this is how it looks like from the top view. Obviously, it looks kind of messy all around it, but don't worry. You know, every construction site gets a little messy, but later on, you clean it up, polish it, and like nothing happens. You know, it's like nothing. It's a very clean connection. Um, Here's just some more pictures of it as well. How to go about it, how to install them. Also, you can see a little bit of prefabrication here as well. Um, See here like how it's clean. So I did talk about tolerances and how why it's important, both and also talked about the seismic activity as well, how that's also something to think about. So we're working with a lab to deal with the how much of a story drift these connectors are able to uh, handle. Um, you can see here that these are just some of the calculations analysis we were able to calculate, but once we get the lab results, we're able to give you actual values instead. Um, and it's real also important because obviously you want to make sure that you know the building does to sway just a little bit, not a lot, you know, but just a little bit, so that it's able to handle the seismic activity. Um, and just some pictures of how the cap, cap capability and how it happens. Yeah, like even if it's a shear load, there is some sort of rotation happening right here, especially since these hangers are pin connections. You know, I don't know if you ever pin something, you can still rotate it, but I always like it's there's a certain amount where like you rotate just a lot and it becomes useless. So you want to make sure there's just a small amount of rotation the capacity is able to handle, but just enough where it becomes is able to still handle the resistant load. So yeah, so that yeah, just to give you an idea how that looks with on a very simple capability. You can see here on there's on two sides you have the pin connection and then you have the roller connection. Handles they both handle shear loads. The But you can see here that even when there's a load in the middle, there is a degree right here of rotation that's happening. So we want to make sure the Alumega is able to handle those rotation. Not to rotate a lot because if it rotates a lot, then what happens is the beam literally just snaps. You just crushed it. So just enough where like it's able to still be this bendable, but not too much, especially if it's wood. I don't know if you ever snapped a piece of wood. It snaps. You don't see it like bends and then it just becomes like a spoon. When you bend a spoon, it's you bend it but you didn't snap it. Wood, um, I don't see that often where you're able to bend the wood that it still stays in shape. That doesn't happen with wood. When you bend the wood, it snaps. So that's what you want. Just to handle just a certain amount before it, but not too much where you have the wood piece snaps in half. So yeah, just give you an understanding of how it looks like from a engineer perspective. Um, yeah. Um, Not only that, we also doing some testing as well for the Alomega, see how much the bolts can handle. The failure mode that does not happen. We calculate the failure modes are not on the bolts; they're usually on the fasteners. But we also still want to test it as well to see the effectiveness behind it. And you can see here like how the failure were to happen if you were to use just on just the bolts. Um, yep. We also done one of my Canadian colleague, and he was able to connect with the lab to do some testing as well with the ALUMEGA. And he was able to calculate it. Like he expected the failure modes to happen around 67 kips, but what actually ended up happening was the beam broke at 52 kips. So the ALUMEGA still stayed in place, but the beam failed first. Um, you can see it's a very short beam, so maybe if it was a bit longer, who knows? Maybe it was in a no a realistic connection. The beam could have been different. The failure mode could have been different. And last but not least, is to give you examples of some the values of the Alumegas. Right now, we're getting it the ICC approval, so that way is able to be used on um, get the certification. And then these are just some values that are based on the fifth percentile. So um, they're not. It's not like the ASD where we use the mean average and then add a safety factor. This is a bit more towards the LRFD values, but just a bit higher. Um, we actually, if you were to reach out to our technical salesman, we're able to provide you some values of them as well. We were able to we were able to finalize the preliminary values, but right now it's being revised by the ICC board. So those values can, not change by a lot, but just change just enough so that it's on the safety side. So some of these values you see here are the values that are expected. So the smallest one from based on calculations and through third-party certification, the smallest one can handle up to 20 kips, and then the bigger one can handle up to 49 kips as well. Now even higher, based on the calculations I saw. So um, yeah, and then this is also another fifth percentile. Obviously, these are very high values. They're not ASD values, so they don't have the safety factor applied. So these are like pushing it just a bit too much. But if you were to pair them up, you're able to pair them up in twos or even threes. These values you can see them happening using ASD values. So yeah. So that's all for today for the Alomega. If you have any questions, you can see the email right here at the bottom. And you can send the emails to eng.na@rotoblast.com, or you can reach out to our technical salesman. They're always on the roll, not 24/7, but like from 8 to 5. So if you have any questions or like this, maybe feel one in person, reach out to your to your representative, and they will able to drop by your door, knock on your door and say hello. Here's the Alumega. Go feel it. Or if you have any questions, they can answer those questions for you as well. Um, and I'm also here as well, along with my colleague Nilu. She's the other U.S. technical consultant, so we're always here to help. And if you're Canadian, we also have our Canadian technical consultant, Milvio. Um, he's also able to help you as well. But if you don't know who to reach out to, just send it to eng.na@rotoblocks.com, and any one of us can answer your question or direct it to the right person. So other than that, thank you for your time. I hope you guys, everybody, stay cool, stay dry, or have a safe day. Hmm.
Awesome. Thank you, Alex. And I just want to share too with everybody that we have our full August list of webinars out on Eventbrite now, so you can go over to our page and check that out. Um, each week we will start with August 6th with anchoring solutions for mass timber. On August 6th, August 13th, we've got waterproofing and airtightness of timber buildings. August 20th is the wall to window connection types and solutions for correct design. And then we're wrapping up August with fall protection systems and solutions for safety. So again, thank you for joining us, and we look forward to seeing you again soon.